Hello, and welcome to Mr. Burgos' channel. Today we're going to be solving number 75 in Chapter 4, Section 12. It states, review conceptual example 16 as background for this problem, which is the figure below. This water skier there has a mass of 73 kilograms. Find the magnitude of the net force acting on the skier when A. She accelerated from rest to a speed of 11 meters per second in 8 seconds, and B. She lets go of the tow rope and glides to a halt in 21 seconds. So let's first start with A. Well, we know that the mass is 73 kilograms, and we have to find the magnitude of the net force, and we know that net force is equal to maximum acceleration. But all we know is that the water skier starts from rest and goes to a speed of 11 meters per second in 8 seconds. So we need to find the acceleration because we don't know the acceleration in order to find the net force. So by using kinematics, we solve for acceleration, and we see that acceleration is 1.375 meters per second squared. Now that we know the acceleration, we can plug it into the net force formula, which is net force equals mass times acceleration, and the mass we know is 73 kilograms, and the acceleration we just found, which is 1.375, so the net force is 1 times 10 to the second newtons. Now, let's solve for B. They're asking to find the magnitude of the net force when she lets go of the tow rope and glides to a halt in 21 seconds. So, since she lets go of the tow rope, we know that the initial velocity is 11 meters per second she was initially going. And then the final velocity would be 0 meters per second because she glides to a halt in 21 seconds, which is the time. So, we have to do the same process. We need to find the acceleration in order to find the net force. So, using kinematics, we solve for acceleration, and we see that our acceleration is negative 0.523 meters per second. We know the reason why it's negative is because we're going to a halt. We're going from 11 meters per second to 0 meters per second, so we're having a negative acceleration, which makes sense. Now that we have the acceleration, we can solve for net force. We know that the net force is maximum acceleration, and since the mass is 73 kilograms, and we just found the acceleration, we find that the net force of the water skier when she lets go of the tow rope is 38 newtons. Thank you for watching, and please subscribe.